I'm Tim Ventura, and we're joined today by Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University. Avi is a theoretical physicist who works on astrophysics and cosmology, formerly the longest-serving chair of Harvard's Department of Astronomy, the founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. Among his many achievements, Avi is a best-selling author, has published over 700 papers and essays, made major contributions to scientific topics, including black holes and gravitational microlensing, and received recognition and awards from dozens of prestigious scientific organizations and academic institutions. So, Avi, welcome back. It is truly an honor to have you with us today.
Thanks for having me. It's a great pleasure.
So we're talking about your recent expedition to recover meteorite fragments in the Pacific Ocean. But before we get into that, I'm wondering if you could start us out with any general updates on the Galileo Project, which is focused on the search for extraterrestrial technological signatures.
We have a working observatory that monitors the sky 24/7 in the infrared, optical, radio, and audio. And at the moment, we are analyzing the data that we get using machine learning algorithms, trying to figure out whether we can separate birds from balloons, drones, airplanes, and look for anything else beyond that. And this is work in progress, and we are planning 5 copies already of this observatory to be placed in many geographical locations. The key is to have tens of those systems in many places, including those where reports about unidentified anomalous phenomena came from. And we just need better quality data that is not anecdotal. That's the key point, that in the past, the reports came from people just being at the right time, at the right place, claiming they saw something unusual. But if there is a systematic study of the sky that identifies things that are unusual, then you can calibrate how frequently they show up, how unusual they are, because you have the baseline of the background. And also you're doing it with well-calibrated and well-monitored instrumentation. So that's the way scientific research is done. And we are trying to bring it into the focus of the scientific community. At the same time, of course, there is a study by NASA that should deliver a report this month, and it will presumably reiterate the points that the Galileo Project is already engaged with. This is the main branch of the Galileo Project at the moment, but we have 2 other branches. One that you mentioned, the expeditions to retrieve materials from interstellar meteors. These are objects that came from outside the solar system. So we can talk about one that we just finished. And then the 3rd branch has to do with objects that do not collide with Earth, that just pass near Earth. And on that, hopefully the Rubin Observatory will start delivering data in a year, and we will pursue interesting objects that are moving too fast to be bound to the sun.
Well, and I will put links into the Galileo Project, and I want to urge everyone in the audience to visit that and look at how they can get involved, try and support your work there, because I think it is so incredibly invaluable. So the Galileo Project website lists an impressive collection of over 50 scientists, engineers, and highly credentialed subject matter experts from across government, academia, and industry who are contributing to it. And that list is growing. So I'm wondering if you view the growth and the support for this project as a vote of confidence from the scientific community.
Yes, I do. And also the government is engaged and is talking seriously about these matters. And the public cares a lot about it. And I think the interest will just grow as we collect more evidence, more data, because that's the key for acquiring new knowledge. I actually have a book coming out next month, August 2023, that is called Interstellar. And it summarizes both the Galileo Project, but also the implications for humanity if we find anything. So that is August 2023, next month. If you're interested in seeing more details on this subject, have a look.
Wonderful. And that's something that people should be able to get on Amazon, right?
Yes, it's already possible to pre-order it because it's only a month away, and basically on any outlet that sells book.
Wonderful. Wonderful. Well, so extraterrestrial technology in general is making headlines right now. Former intelligence officer David Grush and Marco Rubio, the senator, are talking about recovered spacecraft. House Representative Tim Burchett says that there will be congressional hearings on it this month. Do you have any opinions on that story that you can share? And do you think, in general terms, that that's a sign of growing public interest in ET and humanity's place in the universe?
Well, the fundamental question is whether there is fire behind this smoke. In other words, they're talking about something that is extremely intriguing, if true. And they haven't shown us the actual evidence. We have not seen the materials or the studies that the government presumably is conducting according to these reports. And until we see them, it's just hearsay. I mean, this is people talking about it, but it's not equivalent to actually seeing the actual evidence. And I very much hope that the government will come forward. But as a scientist, driven by data and evidence, I'm ready to collect the evidence myself. And, the sky is not classified, the oceans are not classified. And so as a result, we are trying to, within the Galileo Project, to get to the evidence without going through the government. I realized when going to the Pacific Ocean last month that it may be easier to find information about interstellar space at the bottom of the Pacific Ocean, 2 kilometers deep, than it is to get it from government. And I should also say that information on interstellar space should not be a matter of national security, because it should be human knowledge that is shared by all humans, just like science, scientific knowledge in general is, because any such visitor from outer space does not adhere to national borders. For them, we are all one, Earthlings.
Well, since you touched on your recent expedition, between June 14th and 28th, you led a team that was searching for meteorite fragments over 108 square miles of ocean floor off the coast of Manus Island in Papau, New Guinea. So can you tell me a little bit about the trip itself? I saw some photos and it looked amazing.
Yeah, I have 38 diary reports on medium.com. If you just Google Avi Loeb on medium.com, and millions of people around the world monitor them. It was an amazing experience for me because, it's a way of testing an idea. This meteorite apparently was moving very fast, faster than 95% than all stars in the vicinity of the sun. So even relative to nearby stars, it was moving fast at 60 kilometers per second outside the solar system. It was not bound to the sun. And the government, the US Space Command confirmed that at the 99.99%, it is interstellar. And on top of that, the government released data on the fireball from which we inferred that it has material strength, the meteorite, tougher than all space rocks, 272 that NASA included in its catalog over the past decade. So if you think about an object that has very high material strength and also moves fast, the thing that comes to mind is a spacecraft, something like New Horizons that we launched. And when it gets to interstellar space, it would move faster than expected because it had some propulsion. And moreover, if it collides with another planet in a few billion years, and just a planet like the Earth, it would appear as a meteor there with a high material strength because it's made of an alloy, not of a natural rock. And so to explore this possibility, we decided to go into the Pacific Ocean and collect the materials. And it's one of these instances where you can see science in action, in the sense that, we're seeking evidence for something that came from outside the solar system and trying to figure out what it was. And we built a sled that was covered with magnets on both sides. And the idea was to put it on the ocean floor and drag it with the ship as it's connected by a cable to the ship. And in the first a couple of days, we had difficulties keeping it on the floor because the cable would lift it, but like a kite. But eventually we got it on the floor by going with the currents, and we started collecting materials, most of which was volcanic ash, a black powder that you can see in this vial that I have that was delivered to my doorstep by FedEx just over the past week. And I realized that some of the material here was delivered to Earth over probably billions of years. That was the journey, the duration of the journey. But we realized that within this black ash, these are tiny particles that we can filter out. The bigger particles are actually originated. They came from the meteor. They are what we call spherules. We saw them through a microscope digital image, as beautiful metallic marbles that are very distinct in the background. We collected more than 50 of them on the ship by using tweezers and trying to take them out. We saw many more that are much smaller and we couldn't pick up with the tweezers. They were typically between a tenth of a millimeter to a millimeter, so really tiny, roughly a milligram in mass. Altogether, we have of order 50 milligrams of such spherules by now. We just found some more after coming back on land. But altogether, the idea is these are molten droplets from the surface of the meteorite when it was exposed to the immense heat from the fireball that released a few percent of the Hiroshima atomic bomb energy and basically melted the surface. And what we are planning to do is examine the composition of these spherules because they can tell us about the origin of the object. So the first question is, can we tell the difference between the materials of these spherules and the solar system meteorites? For that, we are examining the composition in terms of elements, in terms of radioactive isotopes that have a finite lifespan, so they can tell us something about the duration of the journey or the age of the material, which could be different than the age of the solar system, most likely, if it came from somewhere else. That once we realize that indeed the materials are different from solar system meteorites, then the next question is whether they are technological in origin. For example, imagine melting New Horizons that I mentioned before. Obviously, the abundance of various elements will be different than nature provides. And if you melt computer screens or semiconductors, you will get rare elements at much higher abundance than you find in nature. So there is a way of telling whether it's technological, and we hope to examine and test that. And I distributed the materials between three groups. One, the bulk of the material is at Harvard University. There is some that was left on the way to Harvard at UC Berkeley, and another small part that it was sent to Berlin in Germany to the Bruker Corporation there that has access to equipment that is state of the art in the world. And by sharing it with three teams, I would like to obtain a good objective judgment as to the origin of this material that is not biased, and we will be confident before we put it in a paper that will be submitted for publication in a peer-reviewed journal, hopefully within the coming month.
Well, and this entire project seems like a real victory for astronomy and science just from the very beginning. The meteorite that these came from crashed in 2014, and based on the speed and direction of origin, in a 2019 paper, yourself and Harvard undergrad student Amir Siraj calculated with 99 to 39% certainty that IM-1 had traveled to Earth from another star, making this a true interstellar object, right? So from the beginning, it's basically doing the science to determine this didn't come from within the solar system.
And
That's
I
really
should add that this is the first object that humans identified as coming from outside the solar system. The other object that is widely known is Oumuamua, but that was discovered in October 2017, almost 4 years later. And the way I came across this meteor was because I was interviewed in January 2019 for a radio in New York City, a radio station, and it was about a meteor that was spotted just a month earlier in December 2018 over the Bering Sea. And in trying to learn about it, I saw this catalog that NASA compiled of meteors with velocity information. So I asked my undergraduate student, because I was very much intrigued by Oumuamua, to check this catalog and see whether there is any fast-moving object, and we found this meteor. So it was serendipitous. I didn't know in advance about it, and that's why it took 5 years to recognize it. But by now, we went to the place, and we found that these spherules primarily along the meteor path. And we narrowed down the region of the meteor path based on data from a seismometer in Manus Island, Papua New Guinea, that measured the sound wave, the boom, the explosion, and knowing the speed of sound and the time delay between the event as recorded by satellites and the sound that arrived to Manus Island, we could tell how far it is from the seismometer, and therefore we got a very narrow, most likely path for the meteor, which was 1 kilometer wide. And we went there with a ship, and we found most of the spherules around that. So that, I mean, we also went to control regions, but didn't find as many over there. So altogether, you know, we have some preliminary evidence that we found the materials from this meteor, but we have to examine them. And of course, there was a lot of pushback from the scientific community, because this is a very important, if true, if this is indeed the first time that humans put their hands on materials from a large object, in this case, bigger than 0.5 meter, that came from outside the solar system, it's a big deal, irrespective of whether it's natural or artificial in origin. And there was a lot of pushback arguing, oh, we can't believe the US government, even a year after the US Space Command issued a letter to NASA saying it's interstellar still. A couple of weeks ago, there was a paper arguing that it may not be. And also the same paper argued that it cannot be made of iron, that their model doesn't fit the data from the government. And we came back with these spherules, and the first thing we found on the ship was that they're made mostly of iron. So I have better confidence in the US government data and the sensors, and I sleep better at night because these are the same sensors that are protecting the US against ballistic missiles. If they were off by a factor of 3, as this paper is trying to argue from a couple of weeks ago, then I would worry that they cannot identify where a ballistic missile is heading, whether it's to Mexico or Washington, D.C.
Well, the fact that U.S. Space Command was involved in assisting with this, again, I think that is another tremendous victory for science as well as government and academic collaboration. So they confirmed with almost near certainty, again, 99 to 39%, that the material came from another solar system. Lieutenant General John Shaw and Dr. Joel Moser, chief scientist of the USSF Space Operations Command, did sign a memo on March 1st of 2022, and they confirmed that the velocity estimate that was reported to NASA was sufficiently accurate to indicate an interstellar trajectory. So again, very exciting to see their involvement and participation.
Yeah, and what we found are spherules, tiny specks of dust, basically. But the key is, in principle, we can go back and look for bigger pieces, because they could tell us easily whether it was a rock or a technological gadget. And of course, if it's a gadget, we could see a label saying made on planet Y, or we could also see buttons. And in the last class of the spring semester at Harvard, I asked my students, if we find a gadget with buttons on it, should we press a button? And half of them said no, half of them said yes. And one asked what I would do, and I said I would bring it to a laboratory to examine its features first before engaging with it.
Yeah, yeah. Well, so in the past, you've speculated, again, you mentioned Oumuamua, the interstellar object. You've speculated that that could be an ET artifact, similar in concept to Arthur C. Clarke's 1973 novel Rendezvous with Rama. So I just wanted to put that out there for context for anyone who was kind of wondering how these may fit into things.
Right.
Do you have any thoughts on how many objects like this could potentially be out there, either natural or artificial?
Well, I'm intrigued first by the fact that only over the past decade, we started searching our backyard for objects that came from the street, so to speak. And among these objects, you might find tennis balls that were thrown by a neighbor. If you check your backyard and not assume that everything there must be rocks of the type that you have seen before. And surprisingly, the first two that were reported were this meteor that we talked about, the meteorite that moved faster than 95% of the stars in the vicinity of the sun, and also had material strength higher than all the space rocks cataloged by NASA over the past decade. And the second that was reported, I actually reported first, but second that was chronologically discovered was Oumuamua, and it also appeared weird. Unlike the rocks we're familiar with, it was not a comet. There was no cometary tail around it, like the comets we are familiar with. But nevertheless, it was pushed away from the sun by some mysterious force that cannot be the rocket effect. And it also appeared to be flat. So to me, the fact that you have the first reported objects as being weird is an alert that nature is trying to send us, that perhaps what lies outside the solar system is not what lies inside the solar system. We should just be open-minded to that. Yet, even 2 weeks ago, the paper that was published tries to explain the interstellar meteor in terms of known solar system stones. And it says that they failed to do that, and therefore the data must be wrong. That's not a healthy approach to learning something new. You can't argue the data is wrong just because you cannot fit the data with things that you already know. And the best example is dark matter. We know that we haven't found dark matter in the solar system, yet most of the universe is composed of it. 83% of matter in the universe is from an unknown substance. And imagine cosmologists claiming, oh, we can't fit the data with the matter that we found in the solar system, and therefore the data must be wrong. I mean, that's unacceptable. And that's the approach taken just 2 weeks ago by people who deal with space rocks. So I'm saying let's be modest, open-minded. Now, if you go through the statistics, there should be 1 million objects like this meteor, roughly a meter in size, within the orbit of the Earth around the sun right now. 1 million right now. And the reason that they collide with Earth only once per decade is simply because the cross-sectional area of the Earth is small relative to the area that it defines by orbiting the sun. Okay, so the Earth covers a small fraction of the volume around the sun, and as it goes around the sun, every now and then it crosses the path of one of these once per decade. Every 10 revolutions around the sun, it collides with such an object, meter in size, from interstellar space. And IM-1 was the first that we recognized, but it happens every decade. So there were plenty of such collisions in the past, but we cannot tell in retrospect which of the meteors that which of the meteorites that we find on Earth are from interstellar origin, because we haven't recorded their speed when they approached us. And just by looking at them, we can't tell. So the point is that those million objects that inhabit the orbit of the region within the orbit of the Earth around the sun, they just pass by and get out of the solar system. And there is an ocean full of those. In fact, their abundance in the outskirts of the solar system, the so-called Oort cloud, is higher than the abundance of rocks from the solar system in the Oort cloud. So if you think about the solar system, the outskirts of the solar system, that is very rarefied. There are rocks that belong to the solar system, bound by gravity to the sun, but they are immersed in an ocean of objects that come from interstellar space, not bound to the sun. So the solar system is swimming through that ocean of other objects, and they are more numerous. So in the outskirts of the Oort cloud, there are more interstellar objects than there are solar system objects. When you go close to the sun, solar system asteroids dominate simply because they are left over from the construction project of the planet. So there are many of them that were left behind, like Lego pieces, left near the sun. They are 1,000 times more abundant than interstellar objects. So if you look at rocks on Earth, only 1 in 1,000 of the meteorites would be of interstellar origin. How can we tell? Well, if we now study the first interstellar meteor that was recognized as interstellar, and we find what characterizes it, that would allow us to go back to collections of meteorites and see if 1 in 1,000 has those properties. And that is an interesting possibility. The other thing is, we are used to looking through telescopes to learn what lies outside the solar system. That's the tradition of astronomy. Now we bring in a new perspective to that, and we're studying what lies outside of the solar system using a microscope, not a telescope.
Yeah. Well, and if I could add to that briefly, this goes off my questions list, but I'm actually doing research for an interview on the Drake equation. And one of the things that I'm finding is, mathematically speaking, if we do encounter artifacts or relics, it's far more likely that they would be exactly that. We wouldn't be finding active spaceships coming in. We would be finding fragments, bits and pieces of technology that have been floating out there.
Exactly. I call that space trash, and I make the analogy with plastics in the ocean. Most of the plastic in the ocean is not functional anymore. And by 2050, it will the amount of mass in plastics in the ocean will be bigger than the amount of mass in fish. So and the reason is simple: it keeps accumulating, whereas fish, the mass in fish does not grow much. So you end up with plastics overwhelming the fish, and you can think of the fish as functional objects in the ocean, but the mass in non-functional, basically trash in the ocean, would overwhelm. If you go over a long enough period of time, it keeps accumulating. And the same is true for space trash, because the Milky Way galaxy traps those devices that are not functional anymore by gravity. All the spacecraft that we launched move at tens of kilometers per second speed, and that is more than 10 times too slow to escape from the Milky Way galaxy. So all of these chemical rockets that were launched by technological civilizations over billions of years keep accumulating within the wastebasket of the Milky Way galaxy as it traps them by gravity. So they should still be around us, and there could be a huge background of those, and we just don't know which fraction of all interstellar objects are artificial, technological in origin. That's what we can find by going to the ocean and finding the relics from them.
Well, Avi, on that note, let me thank you so much for your time today. Again, it is truly an honor to be able to interview you. So let me close by asking, again, how the public can help to support both the Galileo Project, as well as asking where we can anticipate seeing you in future headlines.
Well, let me answer the second question. So we are now engaged in the analysis of the materials from the expedition, and hopefully within a month, we'll reach some interesting conclusions on that, preliminary. Obviously, it could take a year before we go through all the materials to the extent that we wish to go through it, but you will hear an update, hopefully within a month, and I very much hope that people will be tuned to that. And also in my book, Interstellar, I discuss very much the implications of whatever we find on interstellar space. And then in terms of support, now we are in the phase of the Galileo Project where we are planning to build more and more observatories to collect evidence that will be open to the public on unidentified anomalous phenomena. And anyone interested in supporting the Galileo Project, we have on the webpage of the Galileo Projects, and we have a button saying support us, and you just click on it, and we would be really grateful for your support. Also, if you have technical skills that could help us, then you can apply for membership, and there is another icon there that you can press on and apply. There is a form that you can fill. And altogether, I think that the expedition in particular demonstrated that science can be exciting and can help us uncover new information about whether we have a neighbor in our cosmic street. And then, that would be amazing if we do find a neighbor, because we can learn from that neighbor. Most likely the neighbor is more advanced than we are, because whatever the neighbor sent reached our doorstep before we reached their doorstep. So let's be open-minded and learn more about what lies in our cosmic street. And I think it's just fascinating to collect that evidence as if we are in a detective story, trying to figure out, what came to our backyard from the cosmic street.
Avi, thank you again so much for your time today, sir.
Thanks for having me.